Morning, 6th grade. Welcome to Math Lesson 4. We always start with a quiz on the backside from Lesson 3. Best of luck with that. When you're done with that, you flip it over. You got the power-up that you've been doing. It's still A. And then you have the mental math section. Quick review. Remember, score equals 20 and dozen equals 12. So when they ask you what are 2 dozen, you take 2 times 12 and get 24. If they ask you what's 3 score, it's 3 times 20. It's a vocabulary word we have to learn. And then you'll notice the first time when you get down to problem solving, they don't give you the explanation for the answer. So you have your first time where you have to do it yourself. You get the challenge of attempting it, and then we'll work through it at the end to see how you did. So pause the video now and give this a go. I'll be back in a second and we'll work through the problem solving and then into our lesson. Problem solving reads like this. Lawrence drew a closed shape with a wide gray marker. So I have it drawn on the board. A closed shape just simply means you stop where you started, so that there's no open spaces. Then Marta drew a closed shape with a thin black pen. Marta's shape crosses Lawrence's shape exactly 8 times. Is it possible for Marta to draw a closed shape that crosses Lawrence's shape only 7 times? So I just challenged myself and did it. So I started here. And I'm Marta now, and I go cross once, cross twice, cross 3 times, cross 4 times, cross 5 times, cross 6 times, cross 7 times. It's not closed. I'm not back where I started. If I tried to get back where I started, I would have crossed 8 times. So the answer is no. You might have noticed something as you were drawing that. When I crossed once, I was inside. When I crossed twice, I was outside. 3 times inside, 4 times outside. So every even number put me back on the outside where I want it to be. Every odd number put me inside where I didn't want to be. So if they ask you a question, what happens if she crosses 11 times? Nope. What happens if she crosses 14 times? Yep. Even yes, odds no. All right. We're ready to get into Lesson 4. Before we get into Lesson 4, let's quick review Lesson 3. Lesson 3 was finding missing numbers. Anytime I'm missing a number in addition, I subtract to find my missing added. Anytime I'm missing something in multiplication, I always divide to find my missing factor. So addition and multiplication, they're always the opposite. Subtraction and division are a little bit different. I need to do some thinking. If I'm missing the first one in subtraction, I add. If I'm missing the second one in subtraction, I still subtract. Remember, we talked about putting the S's together. Second, still subtract. The other thing we talked about doing with subtraction is just writing it backwards. So if I had 5 minus 3 equals x, I would just put in reverse. X plus 3 equals 5. And lots of times we work really well when it comes to those addition problems. With division, if I'm missing the dividend, I multiply. If I'm missing the divisor, I divide. We talked about the long I's to be able to help try to keep that one straight. Those two, subtraction and division, take a lot of practice because they can be tricky because sometimes they're the opposites. Okay, Lesson 4, we're talking about number lines and sequences today. Have your yellow folder open, ready to fill in some blanks. We'll get going with our lesson. It says this. A number line is used to help us arrange numbers in order. You got your first blank in your yellow folder, puts things in order. Each number corresponds to a unique point on the number line. The 0 point of the number line is called the origin. You have another blank filled in. 0 equals origin. We talk about that when we talk about number lines. We're also going to talk about later on in the year when we talk about coordinate planes and graphing. Those things come with origins. It's 0, 0. The numbers to the right of the origin are called positive. They are greater than 0. You have your third blank. Positive, greater than 0. Every positive number has an opposite that's the same distance to the left of the origin. The numbers to the left of the origin are called negative numbers. Negative numbers are less than 0. You have your fourth blank. Negative equals less than 0. 0 is neither positive nor negative, so guys, keep that in mind. When we're working left to right, it's always negative first, then 0, then our positive numbers. 0 is not positive or negative. Continuing on the top of the next page, it says on this number line, the tick marks indicate the location of integers. Integers is our new thing. Lesson 1, we talked about counting numbers, which we called natural numbers, 1, 2, 3, 4, 5. Then we added whole numbers to that. Whole numbers are 0, 1, 2, 3, 4, on forever. Integers now, let's see what they say. Integers include all counting numbers as well as their opposites, their negatives, and the number 0. Integers do not include fractions or any other numbers between the consecutive tick marks on the number line. So into your yellow folder you have what integers are. Integers are counting numbers, their opposite or the negative, and 0. So I like to say integers are whole numbers and their negatives. But there's no fractions there, guys. 2.5 is not an integer. 2.2, there's no decimals, is not an integer as well. So solid whole numbers and their opposites go along with that thing. Paragraph number 2 on page 27, the ellipsis to the left and the right indicate that the number of negative and positive numbers is infinite. Ellipses are those 3 dots. Infinite means it goes on for forever. So they're not going to write every number, obviously, because numbers never end. Notice that the negative numbers are written with a negative sign. For -5, we would say -5, not subtract 5. Positive numbers may be written with or without the positive sign. So I might have the plus sign. I don't say both plus 5. I say both positive 5 and 5 are positive, and they're equal to each other. Normally, obviously, we don't put plus signs in front of positive numbers. That's just not how we write. We always assume a number. If you see a number, you say, that's positive. If I want negative, I got to put a negative sign there. But as we move through this year, we're going to have problems that have a lot of positive and negative numbers together, and so they'll put the positive sign there a lot just so that you know exactly what the book has in mind. Third paragraph. As we move to the right on a number line, the numbers become greater and greater. As we move to the left on a number line, the numbers become less and less. A number is greater than another number if it is further to the right on a number line. We compare two numbers by determining whether one is greater than the other or whether the numbers are equal. We place a comparison symbol between two numbers to show the comparison. Comparison symbols are choice 1, the equal sign, choice 2, the greater than sign, or choice 3, the less than sign. We write the greater than and less than symbols so that the smaller end, the point of it, points to the number that is less. Below we show 3 comparisons. -5 is less than +4. Negatives are always less than positive numbers. Even though 5 looks bigger because it's a 5 and the other one's a 4, negative is always less than. 3 plus 2 is 5, so they wrote equals because that looks like a normal problem to us, but the left is the same as the right, so they equal each other, and 5 is greater than -6. So in your notes, guys, I wrote down compare, determine which is greater, and then we have those symbols. So what your book said is, we always point to the smaller one. When I was growing up, Pac-Man was a big game, and you were trying to eat points, and so this little mouth going around, chomp, 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 and so I was taught, you want to eat as much as you can, you want to eat the biggest amount of points. So I always looked at it not point to the smaller number, but eat the bigger number, okay? So just stressing there's always a number of ways to think about it. You figure out which one pops into your head and sticks into your head so that we can do those things. Let's start working a few examples. First of all, you have example 1. It says put these numbers in order from least to greatest. Now they gave us 3, and then the only other helpful hint I'll give you guys, make sure you read carefully. Also in the next problem they'll give you, most of the time they'll say least to greatest, but every once in a while they'll say from greatest to least, just to make sure you're reading. So because they gave me one of each type of number, this one's actually easy. Negatives always come first, but there's only one negative, so it's got to be the least number. Then there's the in-between, the one that's not positive or negative, which is 0, that's got to be second. And then there's one positive number, that's got to be last. So in order it goes from -2 to 0 to 1. Example number 2 says, rewrite the expression below by replacing the circle with the correct comparison, then use words to write the comparison. So I have -5 and I have 3. -5 is always smaller, negative smaller. I want to eat the positive, so I put the symbol in there. Then they told me, can you write that? In other words, can you actually read this sentence in English? So I write -5 is, and what they're really challenging me is, can you tell your symbols? That's the greater than sign, is greater than 3. So 6, just make sure we're reading those. So often when they give you 2 questions in the same problem, we're like, all right, done. I put my symbol in there and I'm done. And I forget the thing where it said, hey, you need to write this thing in words. So make sure you're writing that thing in words. Turning the page, It says we can use a number line to help us add and subtract. We will use arrows to show addition and subtraction. To add, we let the arrow point to the right. To subtract, we let the arrow point to the left. Number 3 says, show this addition problem on a number line 3 plus 2. Just remember, adding moves you to the right, subtracting moves you to the left. Guys, 3 plus 2 equals 5. I am not taking the time to write a number line to say 3 plus 2 is 5. You've been doing that for a number of years in your life. Example number 4, same thing. I'm not drawing a number line. 5 minus 3 is 2. I know that. I've known that for a number of years in my life. It's subtraction. The reason I had you doing that is practice, because here's the new concept they're really teaching today, what we do when we get to negative numbers. Number 5 says, hey, if you had a number line that looked like this, so I got 1, 2, 3, 0, negative 1, negative 2, negative 3. I would move to the right 3, so I'd start right here. Then 5 says move to the left, so 1, 2, 3, 4, 5, and I get down here to negative 2. That's what they wanted you to do for example 2. On the next page, they're going to explain how we can do this without drawing number lines. Top of page 29. It says, together example 4 and 5 shows graphically that subtraction is not cumulative. In other words, cumulative from lesson 2, order doesn't matter. That only works with addition and multiplication. In subtraction, order does matter. One way, I got 2. Opposite way, I got negative 2. So that is that the number affects the outcome of subtraction. In fact, if we notice, reversing the order results in opposite differences. So the one way gave me positive 2, the next way gave me negative 2. We can use this now for example number 6. Now I like example number 6, guys. Here's why I don't draw number lines. It's not because I don't like to listen to my math book when my math book tells me to draw number lines. But when we get to problems like this, guys, your math book's not going to say draw a number line like this. You're not drawing a number line 840 long. So what we say is, hey, this is backwards. It's going to be the opposite of what I know. When I learn math, I always got positive answers. Bigger on top gave me a positive answer. Now it's the opposite. It's going to be a negative. So I put 840 on top, and I subtract 376 from it. Cross, borrow, 4, cross, borrow, 6, and now I have 7 minus 3 is 4. Now what I need to remember is, it's the opposite of what I thought. So it's negative 464. So what they're trying to teach you guys is anytime the smaller number is first, do the subtraction like you normally would, putting the bigger number on top, but just remember at the end, you have to make it negative. When your book tells you, hey, please do this problem and draw a number line, 6, the choice is yours. This is the first time you're working with negative numbers and you think this helps you, please do it. If you're like, Mr. Bauer, I really don't want to waste my time, I know that I have to give the opposite and get a negative answer, you don't have to draw the number line for me. Okay, that was number lines. Second part of our lesson talks about sequence. A sequence is an ordered list of terms that follow a certain pattern or rule. A list of whole numbers is an example of a sequence, 0, 1, 2, 3, 4. If you're back to your notes, you have the last blank filled in. A sequence follows a certain, I use the word rule, you can use the word pattern, whatever clicks best for your brain, doesn't matter to me. If we wish to have a list of even and odd whole numbers, we could write them like this. Even, 0, 2, 4, 6, 8. Odds, 1, 3, 5, 7. Okay, we know those lists. Now, what they're going to talk about is the 2 different types of sequences. These sequences are called arithmetic sequences because the same number is added to each term. Thus, the number in the sequences are equally spaced on a number line. So I'm adding by 2s, right? 0, 2, 4, 6, 8, every other one. 1, 3, 5, 7, 11, every other one. Okay, so that's all they're showing. Turn the page, there's another way to do it. A different sequence would look like this. 1, 2, 4, 8, 16. That's not adding 2 each time. That's adding 1 and then adding 2 and then adding, whoa, if we're not adding the same number, we're not adding. This is called a geometric sequence because the term is multiplied by the same number for the next term. Terms in a geometric sequence are not equally spaced. They'll get spaced out farther and farther the farther you go. To continue a sequence, study the sequence to understand its pattern or rule and then apply them for the additional terms. Let's work a few of these. Number 7 says, the first 4 terms in a sequence below, find the next 3 terms. They gave me 1, 4, 9, 16. Now what I notice, guys, is I'm not adding the same number each time. So it's not an arithmetic one, it's not an addition one. It's a geometric one, I'm multiplying something. But I would say, how did I get from 1 to 4? Times 4. 4 times 4 is not 9. This one's one that you need to recognize, but it's a little bit tricky. 1 times 1 gives me 1. 2 times 2 gives me 4. 3 times 3 gives me 9. 4 times 4 gives me 16. So my pattern is really this. I'm going up by perfect squares. 6, they're going to give you this pattern all the time in your book. So if you don't instantly recognize this as 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, they ask me the next 3 terms, to 25, 36, and 49. I would highly recommend you putting this into your notes somewhere so that you can recognize that one. If you were sitting in my classroom, I have a beautiful poster on the wall, this little guy right over here, that gives you the perfect squares for 25, but tragically you're not sitting in my classroom, so you don't have that. So you might want to write the perfect squares or find perfect squares on the internet. Just make sure you recognize that one. Top of page 31 says this: the rule of the sequence might be expressed as a formula. A formula for the sequence of the perfect squares is taking k times n times n. The variable n represents the position of the term. In other words, are you doing the first term, second term, third term? K represents the value, which would be the answer. To find the 8th term in the sequence, we would take 8 times 8 and get 64. So they gave you, hey, how do we get this one? The rule is k equals n times n. Written probably better than that would be k equals n squared. And so now they're saying, we might give you the pattern, and you need to figure out the rule, and we might give you the rule, and you need to figure out the pattern. That's example 8. Example 8 says, the rule of a certain sequence is k equals 2n. Find the first 4 terms of the sequence. So they told me find the first 4. So the first one is 1. Letter next to a number means multiply. 1 times 2 is 2. I'm up to the second term. 2 times 2 is 4. 3 times 2 is 6. 4 times 2 is 8. And I did the next 4 terms. So guys, they might just give you this pattern and say, what's the 12th term? 12 times 2 is 24. So when they give you the rule and they say figure out which term, you just stick that number in and do the math for it. Okay, last helpful hint I'll give you: in the future, they're going to start to put these things together. So right now it's either add by some numbers, you can also subtract. Multiply by some numbers, or you can also divide, or recognize your perfect squares. But the other thing they're going to do in the future is kind of put them together. So the rule is going to really be times 2 plus 1, or divide by 2, subtract 1. And when we keep practicing these for a couple weeks, then they'll start sticking some of those harder ones in there. Okay, your yellow folder should be filled out, your problem should be done. Your to practice set, remember how practice sets work. If you want extra practice, do it. I would highly recommend, 1, working some of those big subtraction problems that are going to give you a negative answer, and then 2, maybe working on some of those sequence ones, like glance at K and L, and there's a few more on the next page if you just want to look and say, can I figure out how these sequences work? And I'll be ready to do math problems with you from the assignment in a second. All right, 6th grade, we're going to try doing math a little bit different when we work these problems, so you don't have to see me running back and forth to the board and everything. Hopefully you'll be able to see my screen and we're doing problems. So the first one I have circled is number 1. It says, what is the difference when the sum of 5 and 4? Sum, once again, means add, so I got 5 plus 4 equals 9. Is subtracted from the product of 3 and 3. Product means multiply, so I got 3 times 3 is 9. Difference means subtract. 9 minus 9 equals 0. Remember, you're showing your work in that left big box. You're writing the answer of 0 over there by where I have circled the number 1. Moving on to number 6. It says arrange these numbers in order from least to greatest. I have -2, 1, 0, and -1. So you notice you have 2 negatives, so I got to pick the one that's farther down the line. That would be -2. Next one would be -1. Then I take the one that's not positive or negative, which would be 0. And then finally, I give the number that's left as 1. That is order from least to greatest. Remember, if you don't have a chance to get this written down, you're going to have to pause the video because as we move to the next one, the screen blanks out. Number 10. I have 4 plus 8 plus n plus 6 equals 30. Step 1, take the numbers I do know. 4 plus 8 plus 6 If I was smart, I would have probably wrote 4 plus 6 because that equals 10, and then add the 8 to that to get 18. Then I'm missing something in addition. To solve that, I subtract. So I got 30 minus 18 equals 12, and I have my answer of 12. Number 11. Z minus 123 equals 654. I'm missing the first number in subtraction. I add. So I put the bigger number on top. I put the smaller number on the bottom. It doesn't matter, guys. Commutative property, either order. 7, 7, 7. Review 11, missing the first, I add. Number 12, missing the second, still subtract. So I have 1,000 minus 101. Cross out 10, 10, 10. Subtract 9, 9, 8. And I get an answer of 899. That goes in my small box. Number 13, I'm missing a number in addition. Missing an addition, you subtract. So I got 495 minus 145. It's money. I'm subtracting. 5 minus 5 is 0. 9 minus 4 is 5. Decimal point straight down. 4 minus 1 is 3. Dollar sign. $3.50. Number 14, 32K equals 224. Letter next to itself means multiply. To solve it, I do the opposite. I divide. So I have 224 divided by 32. And I'm going to look at the 3 and the 22. And I'm going to say 3 goes into 22 7 times. And see if that works. And I wrote the 7 in the wrong spot. 7 times because I'm doing 32, not 3. Sorry. 7 times 2 is 14. Carry the 1. 7 times 3 is 21. Plus 1 is 22. Subtract, get a 0. My answer worked perfectly at the number 7. This little trick of looking at just the first number doesn't always work. Many times it'll work if the second number, guys, is small, if it's close to this one. But if this was like a 38, then that wouldn't work as well. But it gets us started if we're struggling with that. Number 15, I am missing the dividend. When I'm missing the dividend, I multiply. So I take 24 times 8. Start giving yourself those helpful hints. The top number. We want to use vocabulary words like dividend, but that might not always click for us. So the top number, if I'm missing the top, guys, I'll multiply. 8 times 4 is 32. Carry the 3. 2 times 8 is 16 plus 3 is 19. I have an answer of 192. Flipping my assignment sheet over, I'm up to number 16. 16 says, look at the first and second steps to justify it. This is working our problems. So they gave me 4 plus n plus 9 in parentheses. Now the next step was 4 plus 9 plus n in parentheses. Notice this parentheses numbers compared to this one. Same numbers, different order. Different order is commutative. The next one, switch to 4 plus 9 plus n. Now I look. This to this. Here I had 9 and n. Now I have 4 and 9. Different numbers in parentheses. Associative. And then they simply did the math, guys. So change the order, commutative. Change the grouping, change the parentheses, associative. Number 19. I have numbers next to each other in parentheses. That means multiply. So I have 48 times 36. Quick review, parentheses next to each other like that means multiply. It doesn't mean do first because there's nothing to do inside the parentheses. So I'm simply multiplying. 4 times 8 is 48, carry the 4. 6 times 4 is 24, plus 4 is 28. Add a 0 to move me to the tens place. 3 times 8 is 24, carry the 2. 3 times 4 is 12, plus 2 is 6, plus 2 is 14. Now I add those together, I get 8. I get 12. carry the 1. I get 7. I get 1. Remember, this was 36 cents. I'm not going to write what's my answer, 1,728 cents. I'm going to switch it to dollar sign, so the decimal point 12. I have $17.28. Number 21, big division problem. I have 18 going into 9,900. I take 18 into 99, it goes in there 5 times. 5 times 8 is 40. 5 times 1 is 5, plus 4 is 9. I subtract, I bring down, get a 9, bring down the 0. I already know this one, guys, it's right there. So it's 5 again, that's going to be 90, and it goes into 0 times to hold a place value. I have 550. Okay, if you wanted to write it all out, you feel free to write it all out, but I can start to see this math going, guys. I'd already done it there. I don't need to do it again in my head. Number 23, parentheses mean do it first, so I start with 130 minus 57. Cross out this, make it a 12, and I have 10. 10 minus 7 is 3. 12 minus 5 is 7. I now take my 73 and I have to add 9 to it. 3 and 9 is 12. Carry the 1. 1 and 7 is 8. And I have an answer of 82. 24, a subtraction problem. I notice that the answers are backwards. So I'm going to put the bigger number on top like I normally do subtraction. But because I switched the order, I know the answer has to be negative. I know some students that'll literally, as soon as they do that, put a negative sign here so that they don't forget that they have to get a negative. Now it's normal subtraction. 14 minus 7 is 7. Cross out this, cross out this, cross out this. 10 minus 8 is 2. Cancel, cancel, so I have an answer of negative 27. Do not forget that negative sign. Number 27. Big division. I'm going to put 4, 6, 4 in the box. I'm going to put 8 outside the box. Notice what I did? I chopped the 0 off of both of them. So now it's just normal division because as long as you do what's inside the box, the same thing outside the box, you're okay. 8 goes into 46 5 times. That's 40. Gives me a 6. Bring down. Gives me a 4. And 8 goes into 64 8 times. That's a 64, subtract, get a 0. My answer is 58. Do not add that 0 back on. You cross out the zeros on both sides, you're okay. Last but not least is number 29. It says use the numbers 2, 3, and 6 to illustrate the associative property of multiplication. Most 6th graders go like this. 2 times 3 equals 6. That is wrong. That's a fact family. This is bad, 6th grade. They say the associative property. So I write 2 times 3 times 6 equals 2 times 3 times 6. Remember, stays in the same order. Now, what does associative mean? It means group them different. So now you just pick. I'm going to pick on the left. I'm going to put 2 and 3 in parentheses. If I put 2 and 3 in parentheses on the left, I need to put different ones in parentheses on the right. And so I put that there. Going back to the right, 2 times 3 is 6, times 6 is 36. Over here, 3 times 6 is 18, 18 times 2 is 36. They equal each other. Now, you don't need all this stuff on the bottom. You need this. But 6th grade, notice what I crossed off at the top. Do not do 2 times 3 equals 6. Whatever numbers they give you, you write them as a multiplication problem. They equal each other. Same number, order. You got to go 2, 3, 6, 2, 3, 6, and then just switch what's in parentheses. Okay, hopefully this was easier for you to see and hear. We've been having some problems with the microphones at school, and so we're attempting to use different things to try to make it easier. Remember, if you want extra credit in math, do the other 15. Blessings on your day.